my name is Tommy, and today we're talking about the photoelectric effect. So if 496 kilojoules per mole is required to ionize sodium, does an electromagnetic wave with a wavelength of 245 nanometers have enough energy to ionize sodium? So we're going to have to go through these equations I have here. C equals lambda times frequency and E equals Planck's constant times frequency. So we have our wavelength, which is the same, which stands for lambda in the equation. But the problem is it's in nanometers, which is a common unit for wavelength. So we want to change nanometers to meters. Now, a nanometer is 1/1 billionth of a meter. So you have to multiply it by 1/10⁹. And that gives us 2.45 times 10 to the -7th. So now that we have 2.45 times 10 to the -7th, we now need to do 3.00 times 10 to the 8th equals 2.45 times 10 to the -7th times our frequency. So we can divide the speed of light by 2.45 times 10 to the -7th, and that gives us a value of 1.22 times 10 to the 15th. So now that we have our frequency, we can go through the energy equals Planck's constant times frequency. So energy equals Planck's constant, which is 6.626 times 10 to the -34th times our 1.22 times 10 to the 15th, and that equals, well, 8.11 times 10 to the -19th joules per photon. So we're getting very close. All we have to do now is multiply 8.11 times 10 to the -19th by Avogadro's number of photons per mole, and also by 1,000 or 1 kilojoule per 1,000 joules. We get 488 kilojoules per mole. So 496 kilojoules is required to ionize sodium, but we only have 488 from this electromagnetic wave. So this electromagnetic wave does not have enough energy because 488 kilojoules per mole is less than 496 kilojoules per mole. This would not ionize sodium.